Hello everyone, welcome to Vision Stuttgart show. We are at the Valence booth and we have some exciting technology to show you. Let's start with the VA7000 family, the CSI-A-PHY extension technology, part of the MIPI A-PHY standard. We have multiple demos here that shows and explains the value of the HD-based of the A-PHY technology and the VA7000 family. I'm starting with pure competition versus Valence. Let's show you how good is our link. On the right hand side we have a competing technology. On the left side it's a Valence VA7000 link. And we can see here both cameras are working perfectly when there is normal condition, no interference, no EMI or EMC problems. What happens if I will increase the noise level from this signal generator, which will inject evenly to both solutions at the same time? You will notice that when I will turn on the signal generator and inject the noise, the competition one will break first, while the VA7000 will fail. So come closer and see. I'm going to turn on the power of the injector, and you can see minus 6 dBm, everything still works fine. What happens if I go up to minus 3 or minus 4 dBm, you will notice that on this side, very soon you start to see errors coming and failures. So as soon as the interference frequency is hurting the competition, it will freeze and break, exactly what's happening now. The VA7000, the Valence solution, keeps working. And right now, if you get closer again, we are at minus 3 dBm, and I'm going to crank it up to maybe plus 10 dBm. So from minus 3 to plus 10 dBm, I'm still interfering, but our solution keeps working. So even if I go from minus 3 to plus 10, I'm still working, and I'm going to crank it up again. So I'm going up to plus 19 dBm. Plus 19 dBm, and we are still working fine. Our solution will break only around plus 20 or 21 dBm, so 20 dB better than the competition. This is significant difference. So let me break it at 21 or 22, and after a certain time, it will fail again. We have unique mechanisms that helps us handle errors better. We have unique solution that is far more robust than the competition. All right, so let's continue. Please take a shot of the breaking. All right, only at plus 20, 21 dBm we are breaking. Okay, here we have few demos that show more value of our solution compared to the rest of the technologies. We can work in longer distances and crappier cables compared to others. We can work with a very thin coax cable. This one is called RG178. You can see how thin it is. And the value here is that it's very flexible. It can work with moving arms. This one is very long, 40 meters. So each of those solutions is running with 8 megapixel sensor. We are running at 8 gigabit of bandwidth with different type of cables, and it's still working perfectly. In this demo, we show even crappier cable. It's really unshielded twisted pair cable. Come closer and you'll see the cable itself. So we removed the black plastic jacket here, so you could see the actual twisted pair. There is no shield. Look how long it is. Look at the inner connection. So we have 40 meters of cable, unshielded twisted pair, and still have a very solid 4 gigabit link. We have it in different lengths, and very interesting, you will notice that all cables go to one single connector. And this connector is very simple, not a high bandwidth, expensive connector, very low cost. The whole solution is unshielded twisted pair, low cost connector, and still very, very reliable. You can compare this connector to other type of connectors like in here. In this case, these are FACRA connectors with coax cables, a little bit more expensive, less flexible compared to the unshielded twisted pair. So Not only that we carry a very high bandwidth camera content, we also carry control signals, and we also carry important synchronization signals. Here is a great example of this. So in this case, if I won't turn on the synchronization, these two LEDs, the green and the red, will be shown on each of those sensors at the same time. So each camera shows you both of them. We have sent a command through this asking each one of these sensors to work only at the right timing to show only one LED at a time. So this shows only the green, this shows only the red. And it's perfectly done. The timing is hardware synchronization. It's very accurate, very fixed, nanoseconds of jitter, so very professional grade. Behind us some applications that are really utilizing this solution. So let's start with D3 engineering, D3 embedded now. They have embedded the valence transmitter inside. So this is the transmitter side that is inside the camera. So each of those cameras have the transmitter inside, and the receiver chip, it's actually a quad receiver. We can get 4 A-PHY inputs and output CSI to the processor. We're using a reference design with the receiver side. What we're showing here is primarily the partnership that we did with D3 embedded inside the camera with Framos sensor, if you can turn around and show Framos as well, and with low power imaging, all of them embedded the VA7000 inside. So this is great application utilizing the technology of valence. And in this case, we have a very interesting combination of the VA7000 extension with a very interesting sensor from a company called Teledyne E2V. The Optimum 5D sensor is unique. It has the ability to use a single sensor to get a 3D image. So typically a stereoscopic image will require 2 sensors, pretty expensive. In this case, it's a low-cost single sensor that is optimized, and with a unique software from Airy 3D, this whole software package together with the E2V sensor is able to generate a very nice 3D images with this solution. So there you have it. I think if you need more information, you can go on www.valence.com and get a lot of interesting information about our product. Thank you.